everyone, we're going to begin Chapter 3 Functions, Section 3.2. We're going to focus on domain and range. Now, we already talked about domain and range in an earlier video, but we're going to look at domain and range in a more in-depth way. So, the objectives for this lesson is that we will be finding domain of a function defined by an equation. We're actually not graphing piecewise functions, so we can take that part out. Okay. Okay, so example 1, let's do a review. Finding the range of a function as a set of ordered pairs, and finding the domain as well. So find the domain and range of the following function. So you guys have already learned this in a previous video, so why don't you hit pause and write out the domain, write out the range, and then when you're finished, unpause the video and we will go over what those are. Okay, so hopefully you've worked through this. So for this problem, the domain is the list of the x's, and the x's are 1, 2, 3, 4, and 5. So we're just going to list those just like that. 1, 2, 3, 4, and 5. Now the range, those are the y's, and the y's are 5, 5, 15, 25, and 35. So there are 2 5s, but you only have to write it once. So 5, 15, 25, and 35. And we separate each one with a comma. Alright, so now we have a try it. Find the domain of the function for try it number 1. So again, pause the video, and when you come back, we'll go over what the domain is and what the range is. Alright, so for the domain, for the try it, the domain is the list of x's, and the x's are -5, 0, 5, 10, and 15. So we're going to list those. And I usually like to list them in order from smallest to largest. And then the range, 4, 0, -4, -8, -12. So if I listed them in order, the smallest is -12, then -8, then -4, then 0, then 4. There we go. So we have found the domain, we have found the range. And just going back and reviewing, let's make sure both of these are functions. Okay, so in example 1 at the top, we have the x's 1, 2, 3, 4, and 5. None of those repeat, so this is a function. Now, I know they didn't ask if it was a function or not, but it's good to review. This is a function. Okay, so it's good to review. And we see that that is a function because none of the x's repeat. That means that each x is assigned to one and only one y. So then let's try and see if it's 1 to 1. Let's review that. So let's see, are our y's all different? 5, 5, 15, 25, 35. So look here, we have 5 and 5. So since that repeated, that means we have one y that has more than one x associated with it. So we have an output that's associated with multiple inputs. That means that it is not 1 to 1. Okay, if we look at the try it, our domain, -5, 0, 5, 10, 15, they're all different x's, so that means that each x is associated with only one y, so it is a function. So let's look at our y's, 4, 0, -4, -8, -12, all different. So that means each output, each y, is associated with exactly one input. So that means it is 1 to 1. And I just wanted to review that because it's good to make sure that we remember what we are building on. As we are moving on, we need to still understand what a function is and what 1 to 1 is. Now, finding domain and range of a set of ordered pairs or a table is actually pretty simple. You're just listing the x's and the y's. It gets a little bit more complex when we're given an equation or a graph. So that's what we're going to focus on in this video. So, finding the domain of a function defined by an equation. So, before we go into this here, I want to skip down to something called interval notation, because we're going to write the domain and range of equations and graphs in interval notation, and so it's important for us to understand what interval notation is. So a lot of times what will happen is we will write a domain or range in inequality form, such as the domain is all x's that are greater than or equal to 8. Something like that. That could be the domain. And that it is inequality form. We have other notations that we can use. One is set builder notation, the other is interval notation. And so we will focus a lot on interval notation. So let me just show you on the number line. If I were to draw a number line, do a different color. Alright, so let's see, we have the numbers. Here's 7, here's 8, here's 9, here's 10, 11, so on and so forth. Now, I just started my number line close to 8, and I know that I want to graph all the numbers that are greater than 8, because if I'm graphing on the number line this inequality, what I'm trying to do is I'm trying to graph all x's that make this statement true. What are all the x's that are greater than or equal to 8? So the first one is 8. 8 is greater than or equal to 8. And what other numbers are greater than or equal to 8? We have the numbers 9, 10, 11, 12, 13, 14. Also, all the numbers in between, let's say 8 and 9. So 8.5 would be greater than 8. 9.5 would be greater than 8. So it's basically from 8 all the way to infinity, which brings us to our interval notation. Okay, so what happens with interval notation is you're kind of writing out what's happening on the graph. You're saying on the graph, x is all numbers between 8 and infinity. And you just separate those with a comma. So you take the two numbers that your interval falls between and you write them down. One of them may be infinity, it may be negative infinity, or maybe just a regular number, but you put the two numbers separated by a comma. Then here is the important piece. If it equals a number, you will use brackets. If it doesn't equal a number, if it just comes close to it, if it doesn't equal a number, you're going to use parentheses. So in this case, for a number to be greater than or equal to 8, that means it can be 8. It can be 8 or any number above it. We're going to use a bracket because it can equal 8. Now, here's the thing. A number can't equal infinity. Infinity is the idea that numbers go on forever. It's not an actual number. So you can't actually equal infinity. So in that case, we're going to use a parenthesis. And that's what these rules here state. When using interval notation, the smallest number from the interval is written first. The largest number in the interval is written second. following a comma. Just like here, the smallest number in the interval is 8. The highest number is infinity. We write both of those separated by a comma. We use parentheses to signify an endpoint value that is not included, called exclusive, and we use brackets to indicate an endpoint value that is included, and that's called inclusive. So it includes 8, but it can't include technically infinity because infinity keeps going on forever. So that is what interval notation is. Now, if you have multiple intervals, let's say that your domain, I'm just going to write all over here. So let's say that your domain goes from, just going to show you from here to here, and then from here to here. So in that case, you would have 2 separate intervals, and you would union them together, and the union symbol is U. So you would write 2 separate intervals with a U in the middle. And I will show you what I mean when we get to that kind of a question. So let's just practice first. Let's practice writing these inequalities in interval notation. So let's try x is less than or equal to 4. So I'm going to draw a number line. And let's see, here's 0, 1, 2, 3, 4, 5, 6. We go the other way of -1, -2, so on and so forth. Okay, so what numbers are included when we have x is less than or equal to -4? So is 4 included? It is included, so I'll put a point. And then we want all numbers that are less. So what numbers are less? The numbers that are less are 3, 2, 1, 0, -2, all the way down to -infinity. So in interval notation, if you will recall, we put the smallest number first. So this interval goes all the way out to -infinity. So the smallest number that the x could be is -infinity. And the highest number that it could be is 4. Those are the numbers that are less than or equal to 4. Any number between -infinity and 4. So, endpoint, -infinity, it just keeps going. So it can't include infinity technically. So we use parentheses. But is 4 less than or equal to 4? Yes, it does include 4, so we're going to use brackets. So there is x is less than or equal to 4 in interval notation. So you guys try these. X is greater than -3, and x is less than or equal to 5, but greater than -1. And let's try one more. Let's do x is less than -1, or x is greater than 2. So see if you can write these out in interval notation. You don't have to graph them, but I find that when you're getting used to this, sometimes graphing helps. If you kind of shade it on the number line to kind of see what the smallest and the largest point is. Okay, so try these, pause the video, try these, and when you are finished, unpause and we will go over them. Okay, x is greater than -3. So we've got 0. Alright, so does x is greater than -3 include -3? It doesn't, because -3 is not greater than -3. So it doesn't actually include -3, but it includes the number just above it. So it includes all the numbers to the right, greater. All of those numbers are greater than -3. So to write it in interval notation, the smallest number it could be is -3. The highest number it could be is infinity. Now, when I say the smallest number it could be is -3, I'm looking on the graph, and we already stated it can't actually be -3. It's just below what it could be. So that means it's not included. So a parenthesis for the -3, parenthesis for infinity. Alright, so let's look at the next one. We have the numbers -1 and 5. So we want to make sure, oops, I just counted wrong. So 0, 1, 2, 3. I just want to make sure I include both. So this is showing that x is between the numbers -1 and +5. So does that include -1? Well, there's an equal sign there, so yes, it includes -1. If it doesn't include it, we do a circle like we did up here when we said it was just greater than -3 but not equal to. We do an open circle. It can also equal 5, so we can put a point on 5, and so we're going to shade all the numbers that it could possibly equal. It could equal any of the numbers between -1 and 5 inclusive. So we know that the smallest number it could be is -1. The highest number it could be is 5. It can equal both, so we're going to use brackets. And last, we have x is less than -1 and x is greater than 2. So let's see here, 0, 1, 2, 3, 4 on the left, -1, -2, -3, -4. I'm sorry, I said that wrong. 1, 2, 3, 4 on the right, -1, 2, -3, -4 on the left. So if I want to shade all the numbers that are less than -1, that doesn't include -1, so I use an open circle, and I shade all the numbers that are less than that. So go to the left. And then for the other one, x is greater than 2, that doesn't include 2, but it includes all the numbers above that. So go to the right. So this looks like we have two intervals. First, we have the interval between -infinity and -1, and it can't equal either one. And then we have the interval between 2 and infinity. It can't equal either of those, so we use parentheses. And then, because it's both of them, we'll do union, like that. Okay, so we are going to stop right here, let you guys take a break, and we'll pick up with the next video where we left off here.